All right, thank you for joining us today. And in this video, we are going to talk about implicit differentiation. So I'll do something small before we go through the examples that we have, right? So with implicit differentiation, the idea is that, as I said in the previous video, the idea is that with the previous video, we were all the differentiation that we've done, we will be having something like y is equal to x squared plus 2x plus 1, or exponential function or a linear function or something like that, right? But the idea is that now here with the implicit differentiation, a function is in terms of y and also an x. But the idea is that we cannot make y the subject, right? Good. So that is the idea. So if we cannot make y the subject from the equation, then implicit differentiation is the best way of going through the thing, right? So that is the idea. It means that when I differentiate x, I need to also differentiate what? Y at the same time, right? We have two ways of doing it. So in our example, I think everything that we are going to do here is, so I'm going to show you all the two so that we will know how we are going to go through the function, right? So let's assume that I have y to be equal to x, y plus 1. And I'm going to differentiate this with respect to, let me see, x. Then what will be dy over dx? So this one is going to be dy over dx will be equal to, now because this is implicit differentiation, this is like two functions because I have y and x. So I'm going to differentiate this using the product rule. So if we are very good with the product rule now, the product rule says that when I maintain one of the function, I differentiate the other one. Then I differentiate the one, I maintain the one that I differentiated, and then I maintain the one that I differentiate the one that I maintained. Right? So when I maintain x, then I differentiate y. What am I going to get? Dy over what? Dx, right? So I'll have dy over dx plus, then now I'll maintain y and differentiate x, right? So when I differentiate x, I'm going to have dx over dx, which is going to give us 1. Then when I differentiate 1, I'll get 0. So I'm going to have dy over dx to be equal to x dy over dx plus, then y dx over dx is 1. So this is going to give us dy over dx, which is equal to x dy over dx plus y. Now one thing that you need to know is dy over dx, mostly we can replace it, we can make it like y prime. So instead of writing dy over dx, I write y prime. Then this one will be x y prime plus what? Y. So here, if I want to make y the subject, then I subtract minus x y prime here, I subtract minus y prime here. So I'm going to have y prime minus x y prime, which is equal to y. Or the idea is move this one to the left, coming to have something like this. Then I factor y prime out. So here, when I factor y prime out, it will be left with 1. When I factor y prime out, it will be left with x. Now I divide 2 by 1 minus x. I divide 2 by 1 minus x. 1 minus x, 1 minus x. So y prime will be equal to y over 1 minus x. So that is the idea. So you see that we are done with the differentiation, but even our result is still in terms of what? X and y. So that is the implicit. With the explicit, we see that when we are done with the differentiation, if you are not plugging, you are not doing substitution of, let's say, when x is equal to 2 or something like that, you see that the function will be in terms of only x because it's explicit. It does not depend on y, right? The same example that we have here, you see the way I did it. We assume that we are differentiating with respect to what? X. Now let's assume that we are differentiating this one to new variable, let's say t. Then this one will be dy over dt, which will be equal to Now we need to use the product rule again. So this one will be I maintain x, then I differentiate y with respect to t. Plus now I maintain y and I differentiate x with respect to t. When I differentiate one, I'm going to get 0. So what am I going to get? This one will be dy over dt is equal to x, dy over dt plus y. Now this one we are not going to get 1 as we had here. Why? Because this one we were differentiating with respect to x. So here we had dx over dx. Now this one is dx over dt. So still we are going to have it to be dx over dt also in. So that is the difference between when I'm differentiating this function with one of the variable in, which is x. It means that when I get to, since I'm differentiating with respect to x, when I differentiate with respect to x and I get to the variable x, that one should give me 1. Do you get it? Good. But when I'm not differentiating with any of the variable, then I cannot get 1 in. All of them will be divided by dt dt. Do you get it? So this is what we are going to also get. So this is the implicit what differentiation. Implicit differentiation has all the rules of how to differentiate the function, the same thing. The only thing is that now we are having y and x together. So example will be like if I have y to be equal to y squared divided by x. This one you're going to use the what? The quotient rule, the same idea. You use the same idea. U divided by v, and then you go through the same process. Is that right? So that is the implicit differentiation. So let's go through this example here and then let's see how we can work through. So we have x squared y minus 6, which is equal to 12y plus 3. Now I want to differentiate this function. Now I can see from here that I have two functions. So this is a product rule straight away from here. So here if I'm using the idea of a is equal to x squared, b is equal to y minus 6. So I've already assigned a to this and b to this using the idea of product rule. So I need a prime to be equal to. Now, don't forget, we are differentiating the function with respect to what? T, not x, right? So look at what is going to happen here. When I differentiate the x squared, what am I going to use? Use the power rule. What do you get? When you differentiate x squared, you get what? 2x. But because we are differentiating this with respect to t, not with respect to x, then I'm going to have 2x dx over dt. Because I'm not differentiating it with respect to what? X. The idea is that let me use the idea of chain rule, x squared. So chain rule says that let's first use the power rule. Drop the 2, don't touch the 1 in the parentheses, maintain the function here, which is the same as this. When I drop the 2 down, then subtract 1. When you finish, you multiply it by the derivative of what is inside the bracket. So don't forget the chain rule. So you see, we did the product and quotient rule followed by chain rule before we came here. Good. So now I need to multiply by the derivative of what is inside. But if I'm differentiating this one with respect to x, then when I differentiate x, I'll get 1. So there is no need. I'll just have 2x. But since I'm differentiating with respect to t, then when I differentiate x with respect to t, I'm going to have dx over dt, which is what we have here. That is the idea. Good. Good. So now what will be b prime? B prime will be equal to, now when I differentiate y, what am I going to get? I'm going to have dy over dt because I'm differentiating with respect to t. So product rule says that you can multiply this by this first, followed by this, or you go this followed by this because addition is commutative. So if I'm going it this way, then I'm going to have x squared dy over dt. So this times that, this, then plus, then this times this. So I'm going to have y minus 6 times 2x dx over dt, which is equal to. So what I just did here, the product rule that I did here was just for the left hand side. So which is equal to, I need to differentiate this. Right. So when I'm differentiating this, I have a constant which is multiplying the y. So I'll just write the constant here. When I differentiate y, I get y prime, right? But this one, because it's in terms of t, I'm going to have dy over dt. Then when I differentiate the constant, I'll get 0. So that's 0. So that is the idea. Very simple from there. Now, what are we looking for? We are looking for dx over dt. So we are actually looking for this. But do we even need to simplify? No, we don't need to simplify, but I'll just write one step because everything is provided for us. So x squared dy over dt plus, now just multiply this one by this. I'll have 2x y minus 6 dx over dt, which is equal to 12 dy over dx. So this one we can simplify and make this one a subject, but everything is provided. So we just do direct substitution. When we see dy over dt is equal to 2, so we are going to place 2 here. We are going to also place 2 here. This one is supposed to be t. Then when you see x, you place it by 5, and when you see y, you place it by 12. So let's go. X is 5, so 5 squared. What is dy over dt? 2 times 2 plus 2x. X is 5. What is y? Y is 12. We don't know the x over the t. That is what we are looking for. So now this is equal to 12 times. What is dy over dt? 2. So this is what we are going to get. So the rest is just to simplify. So 5 squared is 25 times 2 plus 10 times 6 dx over dt is equal to 24. So this one will be 50 plus 60 dx over dt, which is equal to 24. I will subtract 50 here, subtract 50 here. In other words, I will move the 50 to the right side. So I'm going to have 60 dx over dt, which is equal to 24 minus 50. And this is going to be 26 minus, so 60 dx over dt. Then I'll divide this one by 60, divide this one by 60. So 60 will cancel 60. So this one will be dx divided by dt, which is going to be minus 26 divided by 60. You can leave it here, or you can say that 2 goes to 26, 13, and goes to this one, 30, and then you leave it here. So this is a lot of work when you are dealing with this one. So please make sure, if you didn't understand, just go back small and then play the video again, and then you watch it again till you understand it, because we have different functions and how you can go through the implicit differentiation, but it goes like the first differentiation. Just like now we have y, we need to also differentiate the x and stuff, right? So that's what you are going to get for the implicit differentiation, right? So let me just keep this function somewhere here so that we can talk about it too. Okay. Now here we want to also find the equation of the tangent again from this, but here too you will see that the function given to us here is implicit. So we are going to use the implicit to do that. Now we are so lucky that we have this one here. So what is the equation of the tangent? I like this one, f of x, which is equal to f prime of x, and then x minus x1. So even let me use x1 here. So luckily for us, I will change this one to y minus y1, which is equal to m x minus x1, because of what is given here. So luckily for us, this is our x1, This is our y1. So I think we have it perfect, right? So this is, then don't forget this m here is f prime of x1. So I will have y minus y1, which is minus 1, which is equal to this m here is f prime of s1. So x1 is minus 4, so f prime of minus 4, then x minus minus 4. So when I simplify it, I'll have y plus 1, which is equal to f prime of minus 4, x plus 4. So this is what you're going to get. Now, what we just need to look for is we need to look for f prime of what? Negative 4. In other words, this here is dy over the x, evaluating it at what? Negative 4. So like this one is like dy over the x, evaluating it at what? Negative 4, when x is equal to negative 4. So it means that we need to pick this equation here and use the implicit differentiation to solve to get our dy over the x. So let's write it here. X squared minus xy plus 3 is equal to 0. Now when I differentiate this, now when you see the function in this form, we are differentiating it with respect to what? X, right? So now when I'm differentiating y to the power something, what am I going to do? Now anytime we are differentiating y, we've done a lot with x. So I know that when I'm differentiating x squared, I get 2x. Use the same idea, right, to deal with y function. So when I'm differentiating y squared, if I'm differentiating x squared, so anytime you are differentiating x of something, think of anytime you are differentiating y of something, think of x of something. So here I know that when I differentiate x squared, I'm going to have 2x. It means that you can think of, okay, y squared should give us something like 2y. Perfect, right? That is how you need to think about. So anytime they give you y function, relate the y to be x and differentiate it. The result that you are going to get, but we are just going to modify it small. So we know that if it is x squared, I could have gotten 2x because I'm differentiating with respect to x. But since it is y, I'm going to have y. I'm going to have 2y because I know that when I differentiate x, I get 2x. So when I differentiate y squared, I'll get 2y. Then here, I would multiply it by dy over dx. The idea is the chain rule that I showed you. The idea is that the chain rule that I showed you, we have y squared. So using the power rule to do this, this is 2 comes down, right? Then you maintain the 1 in the bracket, like everything. Like when the 2 comes down, you will write this one again, then you subtract 1. Then you use the chain rule. Now you differentiate what is inside the bracket. But we are differentiating with respect to x. So either we write y prime or we can also use dy over the x. So when I simplify this, I get 2y dy over the x, which is something right here. Is that right? Good. Now the next thing that I need to do, or I want to do, is now I'm done differentiating this. Which is this? I need to differentiate this, but this is a product rule, right? So I have xy. So xy is the same as ab. So a is equal to x, b is equal to y. A prime is equal to 1 because we are differentiating it with respect to what? X. This one, we were not differentiating it with respect to, let me say, x. If this one were differentiating with respect to x, this one could have given us 2x instead of 2x dx over dt. Is that right? Good. So that's the idea. So this one, since we are differentiating with respect to x, we are going to get 1. Then when I differentiate b, I'll just have y prime, or in other words, I can say dy over dx. Right. So minus, You see, when I wrote the minus, I just open my parenthesis because I know that minus is something that is going to distribute. So product rule, this one multiply this one multiply that. So x times dy over dx plus y times 1, which is going to give us y, plus when I differentiate 3, I'll have 0, which is equal to 0. So now let's try and simplify. Let's try and simplify. But for us to simplify, it's always good when you have point. So this point here that we are calling it x1, y1, the same point, this is x, this is y. That's what we are going to use to do this. So the same point that we are calling it x and x1, y1, the same point, this is x, this is y. But the only thing is that we don't use x and y in the equation, because our equation here should be in terms of x and y. So you cannot plug this one inside the equation direct as x and y. But when you are doing it inside the equation, you call this x1, you call this one y1. But when you find the derivative and you want to do plug in, then you call this one x, you call this one y. So x is minus 4, y is minus 1. So 2 times minus 1 dy over dx minus x is minus 4 dy over dx, then y is minus 1, which is equal to 0. So when I simplify this one will be 2 dy over dx move this one up small, minus 2 dy over dx minus, so I'll multiply minus, so this one will be plus 4 minus minus positive plus 4 dy over dx. And when I multiply the minus 2, I have plus 1 is equal to 0. So this implies that now I have the dy dx here, dy dx here. I can factor it out. So what will be left here is negative 2 and 4, which will be minus 2 plus 4, which is equal to, so I'm going to subtract minus 1 here, minus 1 here. Or in other words, this one moves to the left and become minus 1. Right. Good. So what can I do here? Now let me move this one up small so that I can write it and bring it down. So minus 2 plus 4 will be 2. So I'm going to have dx times 2 minus 1. This is the same as 2 dy over dx, which is equal to minus 1. So dy over dx, divide this one by 2, divide this one by 2. So it's equal to minus 1 over 2. Right? Now here too, I can do it straight. I know that this term and this term are the same. So 4 of dy over dx plus minus of dy over dx is just 2. So it just 2. Then you just get it from straight. So now dy over dx is equal to this, which is the same as the slope that we have here. So this is the same as f prime of minus 4, which is equal to minus 1 over 2. Is that right? Good. So now this is what you are going to get. Now let me modify this one small for you. Now I chose this one because this is what we are familiar with. Now remember, anytime we find our derivative, you see that when we finish the derivative, we saw that we had x and y in it, right? Y, x in it. It means that I will change something small. I'm not going to change the solution. We are done with the solution. So this one will be y plus 1 is equal to, we had minus half x plus 4. So this will be the solution. Good. Now the only thing that I'm changing here is I'm going to rewrite this, like if I'm writing this function here. Now my slope here does not depend on only x1. It depends on x1 and y1. So instead of now with the implicit y minus f of x1, y1 Do you get it? Then which is equal to f prime of x1 y1 then x minus x1. The idea is that you see here, if I want to find for no this one this for this one it should be only x1. Yeah. So with the f prime, you see that when I'm done finding the f prime, it always involve x, and then y. So it means that now it depends on two variables like x and y, instead of when we're dealing with explicit where we have only x, or the function is in terms of y or x only, and then we are done with that. So this will be the equation of the tangent. So equation of the tangent is here. F of x1 is given, which is the same as y1. You do the direct substitution. So minus 4 here, minus 1 here. When you get here, then you differentiate the function, you plug them in, you look for your gradient, and you just come and plug it in. All right, so now let's look at 3. 3 again. 3 2, we want to look at the equation of the tangent. So we just learned that equation of the tangent is y is equal to, let me use y1, which is equal to mx minus x1. Now this is x1, this is y1. So let's plug them in. We are going to have y minus 2, which is equal to mx minus 1. So the only problem here is m. For us to get m, remember m is the derivative. So we need to differentiate this one, plug in this, and then we just come and work with that. So that is the thing that we need to do now. Now when we are finding the differentiation, now this changes from x1, y1 to x and y, right? When we are dealing with the differentiation. So now let's go through the differentiation very quick. We have good. I've not talked about len function, but it's here, so we need to learn how to differentiate this. So with len differentiation, what we do is we use a chain rule, but this is how we differentiate a len function. 1 divided by what's inside the parentheses of the len. So 1 divided by everything in the parentheses here times the derivative of what is inside the parentheses prime. So this is how it's going to be. Let me put this one up here. Bring this one here. So you see what I did? 1 divided by what is inside the parentheses times, then I pick what is inside the parentheses, then I differentiate, which is equal to the same thing here. 1 divided by what is inside the parentheses, which is 5x, times I pick 5x and then differentiate, plus when I differentiate y, what am I going to get? The y over the x, but I want to use the shortcut. I will use y prime. Then when I differentiate 2, I'm going to get 0, so minus 0. Is that right? Good. So I'm going to have 1 divided by x squared plus y squared times. Now I'm differentiating what is here. When I differentiate x squared, what am I going to get? Remember, with equation of the tangent, we differentiate with respect to x. So when I differentiate x squared, I get 2x. Plus, when I differentiate y squared, what am I going to get? I also need to get 2y, but I'll multiply by dy over the dx, which is the same as y prime. And this one is going to be 1 over x. When I differentiate 5x, I'm going to get 5 plus y prime. Minus 0 will just be 0. Right? Let me continue it from here. Now, what I need to do is, you see, anytime I have the point given to me, I don't want to worry myself, doing a lot of expansion. So I'll just plug in x is equal to 1, y is equal to 2 inside this equation. so that it will be very simple for me to find for y prime. So x is 1, so 1 squared plus y is 2 times 2 times 1 plus 2 times 2 y prime, which is equal to, now this one 5 will cancel 5, so I'm going to have 1 divided by x, which is 1 plus y prime. So I'm just using what is here. By here, x is 1, y is what, 2, from the information given to us here. So just do substitution here, 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 and that. So this is going to be 1 divided by 1 plus 4, 2 plus 4y prime. Then this one will be 1 plus y prime. So this is going to be 1 divided by 5, 2 plus 4y prime, 1 plus y prime. So what I'm going to do is I'm going to multiply this side by 5 and multiply this one too by 5, right? When I do that, I'm going to have 5 to cancel 5. So here we'll be left with 2 plus 4y prime, which is equal to, the 5 will distribute. I'm going to have 5 plus 5y prime. Then I need to make y prime the subject. So I'll move this 4x to this side. Now move the 5 to also this side. So I'm going to have 2 minus 5 because I'm moving the 5 to this side. Then it will be equal to 5y prime minus 4y prime because I'm moving this one to this side. In other words, subtract 4y prime here, subtract 4y prime here, which will give us this. Subtract 5 here, subtract 5 here, which is also going to give us this. So this is going to be minus 3, which is equal to 5 minus 4 is 1, so y prime. So y prime is equal to what? Minus 3, which is the m that we are looking for. So now, since we've gotten minus 3, we just plug it in there. 2 is equal to minus 3x minus 1. Very simple. So here, the differentiation matters because you saw that they gave us everything. So we were able to even solve it up to the side. So the only thing that we needed is the m. That is when we need to go to the differentiation before we get it and go and plug it in. So always be careful with the functions that you are going to differentiate, right? Like you should be able to know how to differentiate each function, right? So let me clean up this and look at the next one. So we have this function here, right? And we want to find the q over the p, where p is equal to 10 and then q is equal to what? 4. So the idea is the same thing. This one is like the implicit, like the same thing. And this one is like p here is x and then q is what? Y. So we are doing the same thing here. So since we need the q over the p, we just need to differentiate this. So 2p squared plus q squared is equal to. So one thing about math 2 is that when they change the variable from x to any other variable and y to any other variable, you don't need to get confused. Just look at them as x and y, the same thing, and then do what you want to do. Now we are differentiating the function with respect to p. So it means that this one you can assume or you can look at it as like this function here is x, like 2x squared. So if I want to differentiate this, what am I going to get? I'm going to have 4p. How did I do that? I maintain my 2, then I differentiated p squared. When I differentiate p squared, it's like differentiating x squared. So this one is going to give us 2p. Then I'll multiply by this. So I think I can use it that way. So 2 times 2p. You see, I didn't add anything like dp over dp because dp over dp is 1. Plus this one here, because we are differentiating q with respect to p, you look at this one like y. So when I differentiate y squared, what am I going to get? We said this is going to be 2y y prime, right? So this is going to give us 2q times dq over what? dp. This one we multiply it by dp over what? dp. But dp and dp cancel, which is 1. So that's all. And this is supposed to be equal to what? 0. Now, fortunate for us, we know p, we know q. So for us to solve this, we just need to plug them in. So let me do first step simplification before I plug them. So this one will be 4p plus dq over dp. So what is p? P is 10. So 4 times 10 plus what is q? Q is 4. dq divided by dp is equal to 0. Then this one will be 40 plus 8 dq over dp, which is equal to 0. Then what will be dq over dp? I'll subtract minus 40 here, minus 40 here. In other words, I'll move this one here, which will be 8 dp, dq over dp, which will be equal to minus 40. I'll divide 2 by 8, divide 2 by 8. So I'll have dq divided by dp, which is equal to minus 4 divided by 8, and this is minus 5. All right. So dq over dp is equal to minus 5. Very simple from there. Now we want to go through the same process again, but here, so this one was dq over what? dp, and this is what is called dp over dq. So in other words, if I want to play smart here, then I will just interchange this. I'll bring the top. So this one, if I want to interchange, like this one 2 is over 1, right? So look at this. If I want to do something like p dp over dq, then I need to move this one up and move this one down, which will help me to move this one up and move this one down. So like this one's supposed to be like minus 1 over 5. Let's check if it is true. Okay. So we are going to go through the same process. But here now we are differentiating with the idea of q. Q. So this is what we are going to get. The same equation from there. Now I'm going to have 2. When I differentiate p squared, now because I'm differentiating with respect to q, now my p now looks like y. So I'm going to have 2p times the p over what? The q. Because now the p over the q cannot cancel because they are not the same. Then plus 2q, but this one will be dq over dq, which is going to be 1. So we don't even need to write it. And this one should be equal to 0. Simplify, we have 4p dp over dq plus 2q, which is equal to 0. What is p? P is 10. So we are going to have something like 4 times 10 dp divided by dq plus 2 times q is 4, which is equal to 0. So I'm going to have 40 dp over dq plus 8, which is equal to 0. So I'll move this to this side. In other words, minus 8 minus 8. So 40 dp over dq minus 8. I'll divide this one by 40, divide this one by 40. So I'll have dp over dq to be equal to minus 8 divided by 40. 8 goes to itself 1 and goes to 45. So you see that you've gotten what I just said from the beginning. Reciprocate this and you are going to get this, right? So this dp over dq is equal to minus 1 over 5, which is just reciprocate this. But you need to solve and then confirm that that is right. Good. So the next question again here is we want to find the slope of the tangent. So this one, The question did not ask us to find the equation of the tangent. It just asking us to find the slope. The slope is the m. The m is finding the differentiation at a certain point, right? So given x squared y minus y to the power 3 is equal to 3, what we just need to do is we just need to differentiate, put the point in. So what you are looking for is the slope. We are looking for m, which is the y over what? The x. So first we can see product rule here. So I'll do the product rule straight. So if I'm doing the product rule straight, then I'll maintain x squared, then differentiate y. So when I differentiate y, I'll have y prime, which is the y over the x, plus, then you saw that I maintained this and I differentiated this. Now I'll maintain y and differentiate x squared, which will be 2x. In other words, if we want to use the product formulas, a will be x squared, b will be y, a prime will be 2x, b prime will be equal to y prime. So if I'm doing cross multiplication, this one multiply this, which is x squared y prime, which is here, plus this one multiply this, which is y times 2x, which is also here. Now, when I want to differentiate y to the power 3, I think of differentiating x to the power 3. So based on the power rule, this one is going to be 3y squared. But we are going to multiply it by the idea of the change rule, dy over the x, which I can write it as y prime, which is equal to 0. So what can I do? I don't want to simplify since I have point here. So I can just plug them in. X is 2, so 2 squared y prime, 2 squared y prime plus y is 1, 2 is 2 minus 3 y squared y prime, which is equal to 0. Nice. So this is going to be 4y prime plus, this one will be 4 times 1 is still 4, minus 3y prime is equal to 0. So 4y prime minus 3y prime will be y prime. Then I'll move the 4 to the other side, which is going to give us minus 4. So the slope of the tangent line is minus 4. So that is how we're supposed to do. So if the question asks us for finding the equation of the tangent line, then we need to quote this formula here. And then when we finish, we plug in our minus 4 in the equation of the tangent, right? So I have this one for you. Just do it, put it inside the comment section. So we just this, right? And then this. So you are finding for the x values that will make the functions up. So solve the following equation. Yeah, so that is implicit differentiation, learning how to differentiate lane and using the power rule, using the quotient rule. So we are doing the implicit, but we are using the same rule. So I'm going to do videos on the rules, and then I'll do videos on, how to differentiate each function: polynomial function, exponential function, length function, trig function, a lot of function. Then if you know how to differentiate individual function, then you will be able to do all these things, because you know that, okay, if I see this, this is what I'm going to do. If I see this, this is what I'm going to do. See you in the next